Hello everyone. So today we will solve the third problem of this contest. The problem is minimum operations to sort a permutation. Right? So before we read the problem, I have a great quote for you. It comes from a song called Fanne Khan by Zide Moth, and the lines are something like कोशिश करो बोला कोच ने अगर मारोगे 100 गोल तभी होगा एक पार. I hope this is self-explanatory that you have to hit a ball 100 times just to make sure that if you try it 100 times, then only one ball will definitely go into the goal, right? So that means you have to work very hard to achieve your dreams, right? You might fail many a times, and but after that you will succeed one day, right? So you should not give up, right? So let's read the problem statement now. Before reading, one more small thing. We have a Discord channel. Do join it if you want, right? I will drop the link in the comments, right? So let's read the problem statement. The problem statement is you are given an array nums of length n, where nums is a permutation of numbers in the range 0 to n minus 1. You may perform only these operations: reverse the entire array or rotate left by 1, that is move the first element to the end of the array and rest of the element to the left by 1 position, right? You need to return the minimum number of operations required to sort the array in increasing order. If it is not possible to sort the array using these operations, return a -1. You need to, a permutation is the rearrangement of elements of the array. Really sorry. So let's first understand what is a permutation, right? So permutation is nothing but a rearrangement of all elements from 0 to n minus 1, where every element comes exactly once, right? I hope you know that. If you don't, let's see a small test cases, like which is a permutation. 3 2 0 1 4 is a permutation, whereas 1 1 2 is not a permutation. 0 1 4 is not a permutation. Why? Because 2 and 3 are missing here, right? So I hope things are clear what is a permutation to you, right? Now you need to say that you have two operations, right? Out of these two operations, you can perform any of the operation any number of times, and you need to sort the array, right? Besides that, you need to find the minimum number of operations required for the array, minimum number of operations to sort it, right? All right. So the first operation is reverse. I think reverse is pretty clear to you. How do you reverse an array? Let's say the array was 4 3 2 1 0. Let's say, then you can sort it and it will become 0 1 2 3 4, right? This might not be the case every time. I'm just saying that reversing means doing this, right? And the second is left shift. What is left shift? You shift every element one left to each, right? Like let's say we had 4 1 0 2, right? Let's say we shift one element by left, then what will happen? It will become 1 shifts to here, 0 shifts to here, 2 shifts to here, and this 4 shifts to the last element. So it will become 1 0 2 4, right? So I hope the problem statement is clear to you. Let's look at the test case to understand the example. Let's say 0 2 1, right? The first thing which we can do is simply do a left shift. After doing the left shift, the array would become 2 1 0, and we have taken one operation, right? After this, what we can do is we can simply reverse the array. Reversing the array will give 0 1 and 2. This is +1. So we took a two operations to sort this array. Now this is a sorted array, right? Similarly, you can take this element as well, do a drag and by your side, see how many operations you require, and the answer should be 2 in this case, right? You can read the explanation, right? It is self-explanatory. I'm leaving this for you. The third example doesn't have a valid answer, so it is -1. It's impossible to do that, right? So the constraints are n is 1e5, right? N is equal to 1e5. So we need to write a solution which works in big O of n log n or big O of n, right? We can also do big O of n root n, right? These are the three valid operations or valid time complexity which we could have, right? So let's try to think. Let's first let me give you one observation, right? The first observation that you should take from this problem statement is, let's say you had 3 and these two sides, let's say you had 7 and let's say you had 11, right? Now you tell me, even if you perform any number of operations, any number of operations, wait, any number of operations, will you be able to change the neighbor of 3? No, right? 3's neighbor will always be 7 and 11, right? But you were supposed to have 3's neighbor as 4 and 5, 2, 4 and 2, right? These are the valid neighbors, right? 2 and 3 are the valid neighbors of 3. So even if you apply the operation any number of times, you won't be able to change these values, right? These values will stick with 3 forever, right? Even if you do the left swap operations, let's say this number had a 6, let's say it had a 5, and here it had 1, 2, 3, 4 and all of that, right? Even if you shift this 3, then 7, then 6, see 3 is still there, 3's neighbor are still 7 and 11. Again let's say you shift that, again let's say you shift that, 3, 11, still 3's one neighbor is 11 and other neighbor is still 7, right? So you, इससे आपको छुटकारा मिलेगा ही नहीं, right? So you will be sticked with it for the rest of your life, right? So that means we cannot have an array. Means let's first and we try to understand when will we get an answer -1. When we will get answer -1 is pretty simple, when the array's elements are not in a increasing or decreasing form. Why so? I will make you understand that as well. But as of now, trust me on this part when I say this, because see, when you had a 3, 7 and 11, right, the graph of this would look something like 7 was here, 7 to 3, a downfall, then again a rise, right? So this makes us understand that the neighbors should either you could have an element that increases in this path, right? This is not only the case of failure, right? I'm showing a graph just to make you understand that the change after 3 there should be a 4, so the change shouldn't be this big, right? So you should try to understand the array should be increasing from one side, right? Let's say, what is an increasing array for us? An increasing array is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is an increasing array. Why? Because after this 0, after this 10, we will say 0 came, and this is how is this increasing, right? But if you look at the graph of this this graph is also a smoother graph, right? From 10, what happens is, first we were at 4, we went to 10, then we went to 0, and then again the graph increased, right? So the graph is somewhere a monotonic thing. See, this is a monotonic thing. Again, this is a monotonic thing, right? There is a sequence of things which is happening. It is increasing in every part except for this element, right? But if you look at the other case, the 3, even if this element has a neighbor 0 as a neighbor 1, right? That means there is a possibility that you can rectify your mistake, right? 0 will have somehow get his neighbors back, that is 1, right? 10 has his neighbors back, that is 9, right? So we call this array as increasing array, right? Now what is a decreasing array? Let's try to understand that as well. Decreasing array is, let's say you had a 5, right? Then you had a 4, you had a 3, you had a 0, you had 3, 2, 1, right? This is a decreasing array. Why? 0, next element is 5, then 4, then 3, then 2, then 1. Still, this 0 has its neighbor 1, which is having his back. This 2 has a neighbor of 1 and 3, which is having his back. This 5 has a neighbor 4, which is having his back, right? So we call this array as decreasing array. As of now, you would have understood that what is an increasing array and what is an decreasing array, right? All right. So my first observation might have might have understood that, see, this has a possibility that okay, 1 is left to 0, but if we reverse it or do something, 1 will come on the right side of array, right? If even if you think of just reversing it, as of now, let's talk, if we say that reverse it, what will happen? It will become 3, 5, 0, 1, 2. See, 1 has its neighbor on the right as 0 has its neighbor on the right as 1, right? That is what we wanted, right? So if we have an array as increasing or decrease, and increasing, so you can clearly see that let's say this was increasing, see, right? It's already has 1. We need to do some operations and this will be sorted, right? So I hope till this point you are clear that okay, if we had an array as increasing or decreasing and the neighbors are correctly fitted, right? Only not only increasing or decreasing, the neighbors should be also correctly fitted, right? So in that case we can say the answer is possible, right? Only in these two cases answer is possible, else return a -1, right? Till this point I hope you are on the same pace with me. All right, now let's see what is the minimum number of operations, minimum number of operations required if array is increasing, right? Let's try to understand that, right? Let's say we had an array as increasing array means 0 1 2 3 4 5 6 7, right? Let's look at this. Now the first thought that should come to your mind is, hey beast, why not just do the left shift and get the answer? Let's say this was at index 0 1 2 3 4 5 6 7. Do you trust me that if you do this operation 5 times, this 0 will be at this position, right? Let's say the first operation will bring 0 1 2 3 here and 4 5 6 7 as this is the first operation, right? After this 0 will come here, 0 1 2 3, 4 will come here, 5 6 7. After this 0 1 2 3 4 5 6 7 and so on and so forth. The position will come when it will be 0 1 2 3 4 5 6 and 7, right? And this will be happening in 5 operations, right? So my first thought is do a left shift, right? How many times? The number of times the index, the element 0 is at which index? It is at 5 index. And we saw if we do 5 times left shift, 0 will be at correct position and the rest element will follow him. Are you getting my point? So my first answer 1 will be nothing but index of 0. All right. Okay, I have a more precise way of thinking it, right? Means this might be an answer, but there is another possibility. What is that? Let's look at it, right? Let's say I had let's not say, let's take the same example, 3 2 7 and then we had 0 1 2. So 3 4 5 6 7 0 1 2, right? So let's say what happens if you reverse this array. So reversing an array costs you +1 rupees, right? So this will become 2 1 0 7 6 5 4 3, right? And after that you can shift this 0 3 times. What will happen? This 0 will, after shifting 2 times, it will come to this position, right? And if you shift it one more time, what will happen? It will become 7 6 5 4 3 2 1 0 will come at the last position. So it will take 2 more operations to do that, right? And now if you see, this is a reversed array, right? So it will take +1 more operation and you will have 0 1 2 3 4 5 6 7. So this took 4 operations for you, whereas the previous one took 5 operations, right? So what we can say is the number of operations will be nothing. If you look closely to this now, what was the first array? This was our first initial array and the size of the array is n equal to 8, right? And the index was 0 1 2 3 4 5 6 7, right? So what I can claim from this is, what happens if we reverse the array and then do a left shift few number of times, and that's it, we got our answer, right? So that will cost us how many operations? Okay, so while I was recording, I noticed that I have missed one operations at this point. At this point, I said if you do 2 operations, you will reach to this index, right? But we wanted it to throw it to the end, so we need to add a +1 as well. So the answer to this will be 5, right? Now what my claim was that if my n is 8 and my index at which my 0 is, I can simply derive a formula. The formula to answer 2 is nothing but n minus index of 0, right? Now plus 2. Now you will say, where did this formula come from, right? See, when you reverse this array, this will come to the third index, right? If you reverse it, that will come the second index, right? If we are doing a zero based indexing, right? So it will come to zero based indexing, that is n, which was 8, minus index of 0, which was 5, right? This gives us 3, right? So what I'm trying to say, erase this one or you might get confused. What I'm trying to say, this will come to the second index, right? And if you come to the second index, how many times you need to do the left shift on that to get it to the end of the array? You need to do it thrice, right? 3 times. What do I mean? See, whenever you do a reverse, you came at this position, it was at 0, 1, 2. So it will take you 3 operations to throw it to the very end, right? So what I'm trying to say is 3 is the number of operations, right? After number of 3 operations, what you will do is you will do the reverse. So it will be plus 1. And initially you had already done a reverse. So it will again be a plus 1, right? So I hope this thing is clear to you. If not, reverse the video, means do 10-20 second backs and listen to it again. If you didn't get it, let me repeat it once for you again, right? Let's say you are at index 5, right? And the total length of array is 8, right? So if you reverse this array, this index 0 comes to the index second, right? So in order for you to make this array, this element 0 go to an end, why you want to go to the end? Because you want the array to get reversed, right? If you went through it to the end, now see the array is correctly reversed sorted, right? So it will cause you n minus index operations, right? You saw that, right? If you are in index 2, it took you 3 operations, which is ultimately n minus current index of 0, right? Are you getting it? Plus 2. Why is plus 2 happening? Because we are reversing it twice, right? I hope the problem is now, or the statement logic is clear to you, right? So we can find answer 1 and answer 2 in these 2 operations for an increasing array, right? Now let's look at a decreasing array. Like we will, if you understood this, decreasing array won't be a bigger job for you, right? Wait a second. Yeah. So let's take the array 2 1 0 5 4 3, right? So if you look at this, right, what happens if you simply do left shift to thrice, right? 0 1 2 3 4 5. Why thrice? Because whatever my current index is, if I do it 3 times, it is 2, right? So if I do it 3 times, 0 will come to an end. And again, what it will become? It will become a reversed sorted array. So let's see, 5 4 3 2 1 0. So in 3 operations, which is index of 0 plus 1, we saw that answer can be reversed, and after that simply adding 1 will cause a sorted array, which is 0 1 2 3 4 5, right? So the answer 1, when we are having a decreasing array, I hope you're understanding, this is a decreasing array. How? After 0 we had a 5, then had a 4, then had a 3, then had a 2, then had a 1. So it is a decreasing array, right? So my answer 1 is index of 0 plus 2, right? Now let's say we had a array something like the same array. Let's say we will have 2 1 0 5 4 3, right? What is the second operation which you can do? The second operation which we can do is simply reverse the array, right? Let's try reversing it. Reversing it gives us 3 4 5 0 1 2, right? So this will cause us one operation, and after that you can simply do left shifts. How many times? 0 1 2 3 4 5. These are the indexing, right? Let me write the indexing. Let's cross it. 0 1 2 3 4 5. Now how many times you need to do left shift? You tell me. Exactly thrice, if we do the left shift thrice, then the answer will be sorted. Let's see. Let's do this thrice. This will come to this place at first, then second, then third, 0. Then this will again shift by 3. This will go to the right side, 3 and 5. I hope if you are getting confused, how is this happening? It's my humble request. Do a dry run. Simply, I'm not saying that I won't do a dry run with you. I'm saying that you use your pen and paper and see this, shifting it 5 times, how this came, right? If you do that now, that will help you a lot in problem solving. When you have this will create a muscle memory for you, right? Because whenever you become a bit experienced with the problem solving, you don't need to do this dry run again and again. This will automatically be set in your mind that if I do a left shift thrice, where will all the index come, right? So this will take a +3 operation, and now the array is sorted. So this took 4 operations for us, and this took some let's quickly look at it. If we are at 0, first we did what we did, we simply shifted it thrice, right? And 1 operation for this. So 2 plus 2, here the answer was also 4. So out of these two, the minimum will be our answer. So the second answer will be, what will be the second answer? How can we derive a formula for this? If you look at the index, it was 0, 1, 2, second index. So index, we reversed it, so it becomes index of 0 plus, if we reverse the array, so it will take n minus index of 0, which is 3, 4, 5, 6 was the array's length. So n minus index of 0 will be our answer. N was 6, index of 0 was 2, so it will ultimately be 4, right? So I hope these two things are clear to you, right? That's it. I think the solution might be clear to you why we are doing these many operations, right? So let's look at the code quickly, right? So give me a second for that. Yeah. So what I'm trying to say is, first we will check if our array is increasing, right? If our array is increasing, we will store the answer. Answer will be found by solve function, right? All right. If array is decreasing, we will find the answer by solve function, right? And if the answer is not, if the array is not increasing nor decreasing, then the answer is simply -1, right? Now let's look at how we will find if the array is increasing. So the formula for that is pretty simple, right? So if nums of I plus 1 modulo n is not equal to nums of I plus 1 modulo n, right? This might be a bit frustrating when you see it for the first time, right? But trust me, when you do solve a bit of problems on these types of problems, these will not be a thing to worry, right? If nums of I plus 1 modulo n is not equal to nums of I modulo n, right? Let's take an increasing array, 0, 1, 2, 3, 4, right? So the two problems can only come on these two indices, right? So let's look at these parts. So what I'm trying, okay, so these are the points which I told you might be confusing for us. So let's look at it. So if what was my problem statement? Nums of I plus 1 modulo n, if it's not equal to nums of I plus 1 modulo n, then we are means that is array is not increasing. But this should not be in our case, right? How? Let's look at that. So nums of I plus 1, so 4 plus 1 modulo 5 should be, if it is not equal to that next element, which is 0 modulo 5. Is it true? Let's look at that. 5 modulo 5 is 0 and 0 modulo 5 is 0. So this is true. So array won't fail, means this is increasing, right? Let's look at the next one. This one is the next one. So let's put the value in this. So 0 plus 1 modulo 5 is 1. This should be equal to 0 plus 1 modulo 5, which is 1 only, right? So you see the both elements are equal, so we can prove that okay, this formula works for us, right? So we will say that if nums of I plus 1 modulo n is not equal to this, then we will return a false. Else, if we didn't return a false at any given time, we return a true, right? Similarly, we do for decreasing array. you can do a simple dry run on this to check if the formula works correctly or not. And we are finding the bool decreasing array as well, right? After this, we are finding the solve function. What was the solve function used for? It was used in the increasing array, right? So whenever we had an increasing array, we found that two formula works for us. The first one was simple index of 0, and second was n minus index of 0 plus 2. What is the plus 2? Plus 2 came from reversing the array twice, right? And the answer will be minimum of these two, right? And int solve2 is nothing but int answer 1, which came from index 0 plus 2, and answer 2 was n minus index of 0, right? And answer 2, this is for decreasing array, right? So this one is for increasing array, this one is for decreasing array, and we are simply passing the answer from these two, right? And finally return the answer whichever you got, right? So I hope the problem was clear to you. It was a bit tricky one and bit clumsy one, right? It is not a data structure problem, it is an implementation based problem, right? So if you were unable to solve it, there's no worries to it, right? Try to solve a few problems on these topics, and it will be good, you will be good to go, right? Thanks for watching. If it was helpful, please do subscribe. It will be very helpful for and beneficial for me as well. Thanks for watching. If you have any doubt or any other problem you want me to share, please do drop that in comments, and do join our Discord community as well. Thanks for watching.